All right, guys, today we're going to talk about piecewise functions. Okay, piecewise are partial functions. A piecewise defined function is one which is defined not by a single equation, but by two or more. Okay, two or more. Okay, so if you look at this first graph, you will notice here the blue line here is this first graph. Okay, the x plus 2. It's showing you all functions that are less than or equal to -1 for that function. Okay, so you will notice that's the blue line. Okay, then the red line here in the middle is this function y equals 1, and it's between 1 and 1. And then our green line here at the end is x squared plus 1 with all values greater than or equal to 1. So those are important, okay? These are called, here is our domain restrictions. Okay, that's going to be called our domain restrictions. And they are going to restrict the domain of the function. Okay, the piecewise function shown in the example on the left is continuous. If you remember, last week we talked about continuous because there are no gaps or breaks. So I could take my pencil and I could draw this graph from left to right, and I would never have to pick up my pencil. So that's what continuous means. Okay, not all piecewise functions are going to be continuous. So you have to be careful because they're not all continuous. Okay, so let's look at this first graph here. We're going to graph the first one, and I'm going to do a little t-chart here. And I need to do values less than or equal to 2. So I'm going to do -2, -1, 0, 1, 2. Now, I can plug it in to x, so like -2. So if I put -2 in place of x, that would be +2 plus 5 would give me 7. And if I put -1, that'd be 1 plus 5 will give me 6. Plug 0 in, I get 5. Plug 1 in, I get 4. Plug 2 in, I get 3. So you can do it that way, or you can put it in your graphing calculator and only look at values less than or equal to 2. So at 2, 3, 1, 2, 1, 2, 3, that's going to be a closed dot because of this equal to under here. And then at 1, 4, 0, 5, -1, 6, -2, 7. The only one this here controls is the first one, okay? But since it has the less than or equal to, it's a closed dot, and we're going to graph to the left of 2 because that's where less than 2 is. Okay, now let's look at the second one. So I'm going to do another t-chart here with red. And now I'm going to do values greater than 2. So 2, 3, 4, and 5. If I plug 2 in place of x, 2 times 2 is 4, minus 1 is 3. So 1, 2, 1, 2, 3. Okay, this one is not closed, but since the last one was, you can't open a closed dot. Okay, and then 3 will go in there. 3 times 2 is 6, minus 1 is 5. And then 4, 8 minus 1 is 7. And then that's going to go that way. Okay. So that is a continuous function because I can draw that function now without lifting my pencil. There's no gaps or breaks. All right, so let's look at this first function. We're going to do less than 1. So I'm going to do -2, -1, 0, 1. And I'm going to use my graphing calculator, and I'm going to check my values in the graphing calculator. And so I'm going to put x squared minus 3 in the graphing calculator, And then I'm going to go to my table. And when I'm at my table, I want to look at the values that are less than 1. Okay, so we're going to go here to 1, and I'm going to look at values less than 1 and only use those from the table. So let me pull my calculator up here so we can get those values. So at -2 is at 1, -1's at -2, 0's at -3, and 1's at -2. Now you can pause the video and put this in Desmos or in a graphing calculator and check those values also. So 1, -2 is going to be a closed circle because of that less than or equal to. 1, -2. 0, -3, well, -1, -2. Remember, this is a quadratic. All right, so our quadratic is going to look like this and go off less than 1. All right, now we are going to find the values for -2x plus 3, and we're going to do a t-chart for that, but we're going to do greater than 1. So 1, 2, 3, 4. So when I plug 1 in, or I put it in my graphing calculator, that's -2 plus 1, or plus 3, that gives me 1. I put 2 in, I get -1, 3 in, I get -3, and 4, I get -5. So at 1, 1, that's going to be an open circle. 2, -1, 3, -3, and 4, -5. This is a linear function, so it's going to be a straight line, and that's going to be our graph. This is a discontinuous function for 2 reasons. Number 1, there's a gap here, and number 2, there's an open circle here. Okay, the last one, if I graph the first one, y is equals 3, y is always going to be 3, and I'm doing -2 and less than -2. So here is going to be an open circle at -2, 3. And then everything to the left is going to be graphed. Okay, I'm going to erase that one just so I'll have room for the other 2 t-charts. Here, I'm doing between -2 and 2. All right, so we're going to put that in our graphing calculator, -2x minus 1. We're going to go to the table, and we're going to get the values -2, 3, -1, 1, 0, -1, 1, -3, and 2, -5. Okay, the 2 key parts are this point and this point because those are our end points. So at -2, 3, okay, -2, +3, that will close that circle. And then at 2, -5, it's going to be there. And then we're going to draw a straight line connecting those 2, and you'll see at -1, 1. Hold on, let me fix my line. Hold on a minute. -2, -5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then we're going to draw that. And then there's those points that we didn't label because we didn't have to, because when we connected them, they were there. The key points are these 2, and those both have closed circles. Okay, the last one is x plus 1, and it's going to be greater than 2. All right, so I'm going to do the chart down here, x, y, and we're going to have 2, 3, 4. If I plug 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is 5, and you can also use your graphing calculator. So this is going to be an open circle at 2, 3. 1, 2, 1, 2, 3. And then 3, 4, and 4, 5. And it's going to go off to the left. This is a discontinuous function also. And so that's how you graph piecewise functions. So please look at your plan book for your assignment. And thank you for joining me. Let me know if you have questions.